Hello, this is Mr. Mack. This is the second video on the notes on session 4. Okay, factors to consider when data is collected. We need to consider what the context is. In other words, where we're taking the data from, source of data as well. Sampling method is, have we considered a way to collect the data that doesn't bias the sample? And we make conclusions about the data we've collected, and we also ask, are the conclusions that we've made statistically significant? That's a good question, because it's possible to actually collect data and have something seem to happen, but it could happen by random chance. So usually what we want to do is we want to figure out how sure we are that what seems to be happening with our sample is actually happening. So statistical significance is an important question. Now, a parameter is a numerical measurement describing some characteristic of the population. A statistic is a numerical measurement describing some characteristic of the sample. And what we're talking here about is inferential statistics. If we take a sample and we find its average, for example, does that mean that the population's average is the same as the average of the sample? Well, there are a lot of things to consider. Generally, we say that an average of a random sample is an unbiased estimate of the average of the population. Let's take a look at a few examples. Determine whether the numerical value is a parameter or a statistic. On a high school football team, 2% of the players are vegetarians. Well, if we've found the truth of all the members on the football team, then that would be a parameter, with the football team being the population. The average amount of surveyed utility bills is $176.42. I think the key here is they surveyed some utility bills but didn't survey all of them, so this would be a statistic. For all students taking the SAT in a recent year, the mean mathematics score was 514. For all students, that would make this a parameter. A survey of 1,060 women ages 20 to 29 in the United States found that the standard deviation of their heights is about 2.6 inches. Is the standard deviation of the heights a parameter or a statistic? Again, this would be a statistic because we surveyed 1,060 women. That's not a characteristic of the entire population necessarily. Okay. Randomization is the best defense against bias. If you are selecting data sets out of a population, the best way to eliminate bias is to make sure that everybody that is selected, or everybody in the population, has an equal probability or possibility of being sampled. And you do that by randomly selecting. Now, as we were talking before I paused the video, when we're talking about sampling, in statistics we want to infer, or we want to say that a population has a certain characteristic. And usually what we do is, instead of finding out what everybody thinks or is or does in the whole population, is we take a sample of the population and study that sample and then make predictions about what would be true of the entire population from that sample. The problem with sampling is that when you take the sample, if you just are choosing people let's say you want to know something about their opinions, maybe political opinions or something. If you happen to choose people in a way that they're grouped together so that a lot of them have the same opinions, you can be very wrong in the predictions you make about the population from the sample. Now, that's called introducing bias. So it's very, very important to see if you can't come up with some way to select your sample so that you have truly randomized the sample. In other words, so that you have made each individual as likely to be chosen from your population as any other individual. That's the best way. Now, we've got some things here about randomization. To limit but not eliminate bias, we should select our sample from our population randomly. Random selection eliminates bias in the choice of a sample from a list of populations. Randomizing helps to ensure the sample is representative of the population. Now, here are a list of some different sampling techniques. First of all, you can do a simple random sample. In other words, just somehow choose a purely random way of selecting the members from the population, or the sample from the population. Now, systematic sampling. What you could do is you could say, all right, I'm going to sample the people that come into a grocery store, and the way I'm going to do that is I'm going to count as people enter, and I'm going to take every 15th person or something like that. That would be a systematic way of sampling. Now, cluster sampling is, let's say, for example, you want to find something out about what students think on a certain college campus. And you say, all right, what I'm going to do is I'm going to select 3 dormitories, and I'm going to select a floor on each dormitory, and I'm going to sample everybody on those floors in those dormitories. And that's what we would call a cluster sampling. And then stratified sampling. Here at the school, for example, let's say there's an issue and we want to know what teachers, office workers, and students and administration think about a particular issue. Well, in a stratified sampling, what you would do is you would randomly select members from each of those groups in roughly the same proportion as they are in the population of the school itself, and that would be a stratified sampling. Now, sampling techniques that are not very accurate are convenience sampling and voluntary response sampling. Convenience sampling is a very, very famous case of convenience sampling where one of the newspapers, I think it was the Chicago Sun-Times, was trying to decide whether Dewey or forget who Dewey was running against, the guy that actually won, whether Dewey or the other guy was going to win. And what they did was they called people up on the telephone and asked them who they were going to vote for. And the respondents overwhelmingly said they were going to vote for Dewey. So the Chicago Sun-Times, I believe it was Chicago Sun-Times, actually printed a newspaper with the headline saying Dewey wins, and he didn't win. Now, the problem was they called people, and this was a while back where telephones had not been widely accepted yet. And so a much larger proportion of wealthy families had telephones, and of these wealthy families, a very large proportion of them were Republicans. And so their sample was very biased towards the Republican candidate because of that, because it was convenient for them to sit down at the telephone and dial people. But their method of choosing the sample had not actually given them an opportunity to, an equal opportunity to select any member from the population. And as you all probably know, Dewey did not win. So convenience sampling can introduce bias. Now also, voluntary response sampling can give you some real problems, because if you have an issue, let's say, for example, let's just pick the issue of how old should someone be before they're allowed to operate a motor vehicle by themselves? And if you put a questionnaire out on the corner of a table in the mall with a sign saying, please fill out my sample and give me your opinion. Well, you're going to probably get a lot of 15 and 16-year-olds that have a very, very strong opinion about it. And so a lot of them will probably answer the sample. And then you're going to have probably a number of parents that have an opinion about it, but a lot of the other groups will walk by and say, I don't care. And so they won't really respond to it. And so your voluntary response is introducing bias into your sample in that way. So you've got to watch those kind of things. All right. Now let's take a look at some examples and let's see if we can't figure out what kind of sampling was used. Now, the Poughkeepsie police set up a sobriety checkpoint and they stop every fifth driver and interview them. What kind of sampling is used? Well, if we look back over here at the list of different types of sampling, was it simple random? No, because it was every fifth one. Was it systematic sampling? I think probably that would be the best description for what they're doing. It would be systematic sampling. Number 2, the U.S. Department of Corrections collects data about returning prisoners by randomly selecting 5 federal prisons and surveying all of the prisoners in each of the prisons of the 5 that were selected. What type of sampling is used? Well, it is not simple random sampling, because if you're not in one of those 5 prisons, you're not going to be selected. But everyone in each of the prisons that was selected was sampled, so I would say that that one is probably cluster sampling. They took particular clusters out in a random way and sampled them. All right, now let's try the third one. In the study of college programs, 820 students are randomly selected from those majoring in communications, 1463 from those majoring in business, and 760 students randomly selected from those majoring in history. What type of sampling was used? Now, it doesn't say here that, but I would hope that 820, 1463, and 760 represent the same percentage when you look at the number of students that are majoring in those areas. And if that's the case, then if we go back here, we'll find that what they have done is they've done, what have they done? They've done stratified sampling. They've taken a group from each of the 3 strata. I forget what the majors were, business and history and something else. All right. Now, sampling variability. The truth is, if a population has a certain characteristic and you take a random sample, every time you do take a different random sample, you're going to get slightly different results. So the sample isn't going to be isn't going to have exactly the same characteristic, but they're going to be kind of close. So every sample produces a different estimate of the population. Now, the purpose of sampling is to give us information about a larger population, and the process of drawing conclusions about a population on the basis of a sample is called inference. That's why many times statistics is called inferential statistics. Now, to avoid bias in selecting samples from a list of available individuals, we should rely on random sampling. Now, the larger the sample, the better information you get. If you sample, let's say, for example, you've got a population of 100,000 people and you sample 3 people, you're probably not going to have a very good idea of what's going on. But if you sample 40 or 50 people randomly from the entire population, you're going to have a much better chance of understanding what's going on. Now, the last thing we've got here is an example where we've got 16 hotels, and I'm not even sure I can pronounce all of them. And then it wants us to determine a proportion of the hotels that have an outdoor pool. So we're going to select a random sample of the hotels. And it says in A, use a table of random digits to select a random sample of 4 hotels. Well, now there's a lot of different ways to do this, but let's say we decide we're going to use random numbers here to select a sample of 4 hotels. So first of all, we could okay, now there isn't really a correct answer here. There are a lot of incorrect answers, but there are a lot of different ways you could do this. And so as I'm standing here, I'm saying, all right, this is what I'm going to do. I'm going to randomly select one of these random numbers. So I'm just going to circle this one here. Okay, 3, 4, 4, 7, 6. Now I want to sample 4 hotels. So what I'm going to do is I'm going to take the first number in my random number, and I'm going to count over that many, and that's where I will start selecting. And I'm not actually going to need the last number because we only want 4 hotels. So I'm going to say 1, let's actually have a little thing here. 1, 2, 3. So I'm going to take the palm tree. And then 1, 2, 3, 4. So I'm going to take the Radisson. And then 1, 2, 3, 4. So I'm going to take the Ramada. And then 7. 1, 2, 3, 4, 5, 6, 7. And so I'm going to take the Captiva. Now, if you do that with any of those random numbers, you'll get a different group here. And pretty much with random numbers, every hotel has an equal likelihood of being selected, but that's my sample of 4. You might want to consider how else could you use these numbers to get a random sample. So that concludes this video. And so my class is now going to say, hang on just a minute, guys. Ready? Go.